All right. In the 1980s, it was generally believed that congenital abnormalities affected about 5% of the nation's children. Some people believe that the increase in the number of chemicals in the environment has led to increase in the incidence of abnormalities. A recent study examined 384 children and found that 46 of them showed signs of an abnormality. Is this strong evidence that the risk has increased? So write an appropriate hypothesis. So our null hypothesis would be that P is equal to 0.05 because of the 5%. The alternate, since it's at the risk has increased, it's going to be P is greater than 0.05, so it's going to be right-tailed. Conditions, random, 10%, certainly less than 10% of all. And then success, failure, that's definitely going to be greater than 10, so we're good. So then to perform the mechanics of the test, what is the p-value? So p hat is going to be equal to 46 out of the 384, which is what? You be lazy today?
Nah, I just can't do that.
Oh.
Oh wait, can I?
I really don't care. I just...
Don't work my magic. It's close to 0.2. It's not?
Should be like 0.12.
Oh, well, it's still close-ish.
So then I need to find the standard deviation, which is the square root of 0.05 times 0.95 divided by 384. So we can find the z value and then figure it out. I'll show how to find the z value and then we'll use the one prop z test on the calculator. But it'd be 0.12 minus 0.05 divided by 0.01. And then we get that number. Or we can use the one prop z test of 0.05, 46, 384, and then greater than p0. And then we want to know what the p-value comes out to be.
So like, what was the problem? Like how I couldn't get the answer from last time? You said it didn't like the decimal.
It didn't like the, when we multiplied the two numbers together for the, like, it was either this number or this number, I don't remember. I think it was this one. When we had two things that we needed to multiply to get that number, it gave a decimal. Or it was divided by or something. But this one doesn't have that. You just plug it in.
Oh, so you just gotta.
If there's a problem, you take the decimal off of whatever this number is. But these are whole numbers, so you don't have to worry about it.
For the z value.
Well, z is going to be this, but I need the p-value that comes out of this, which is the number that's below that.
So 1.8.
And then look at the end. So it's basically 0. So then it says to explain carefully what this p-value means in context. So if 5% of kids have birth defects, the probability my sample has 12% is 0. So we got 12% from our sample, but the probability of getting 12% was 0, basically, is what that means. So then what's your conclusion? So this p-value is low, so p is low, which is lower than any reasonable alpha level. So we reject the null hypothesis. And there is enough evidence to suggest the rate has increased. So then, do environmental chemicals cause abnormalities? Do what? Oh.
No.
Okay, so we can't say for sure. Just based on what we have, without running a controlled experiment but we could say that it is possible. All right, so this one, the International Olympic Committee states that the female participation in the 2004 Summer Olympic Games was 42%, even with the new sports such as weightlifting, hammer throw, and modern pentathlon being added to the games. Broadcasting and clothing companies want to change their advertising and marketing strategies if the female participation increases in the next games. An independent sports expert arranged for a random sample of pre-Olympic exhibitions. The sports expert reported that 202 of the 454 athletes in a random sample were women. Is this strong evidence that the participation rate may increase? So we care about this may increase part. So the alternate hypothesis, the null hypothesis is going to be P is equal to 0.42. So that means my alternate is what? Yep. Greater than 0.42. So then conditions, is it random? Yes. 10% condition.
Wait.
Yeah. And success failure, is it going to be greater than 10? Yeah. So then perform the mechanics of the test, find the p-value. So since we're not actually doing it by hand, we don't really have to do this, but just so that you see where we would get it from, we do 202 divided by 454. And then that'll give you the decimal that we would use if we were doing the z equals blah, blah, blah. But we're going to use the calculator, so one prop z test of 0.42, 202, 454, and greater than P0. So then I want that p-value. You already know? Well, congrats. It's always fun to find out like the day, like when they announce it, but that's awesome.
They'll find out on Saturday.
Do you know if anybody else on your team made it?
Elijah, Christian, they all made honor elevation.
Nice.
For the P value, I got 0.1.
So what this means in context is that about 14% of the time I would collect a sample with 44% of women, or with 40, yeah. I'm just going to say participating, I guess. That's a good way to word that. So our conclusion. So the alpha levels that I was talking about yesterday, you kind of, if it doesn't specify, we kind of just go with an understood 0.05 for alpha, meaning that if this number is greater than that, then we're going to fail to reject. So p-value is not lower than alpha equal to 0.05. So we fail to reject. The null hypothesis, meaning that there is enough evidence to say participation rates of women have increased.